Hello, I'm Andy Anderson, Principal Investigator of the Carbon Time Project. Carbon Time is what we call design research. So we're both designing new approaches to instruction, assessment, professional development, and building teacher support networks, and conducting research to understand them better. In this video, you will hear from Carbon Time researchers in 4 different groups: case studies of teachers using Carbon Time, research on assessment and student learning, research on classroom teaching, and research on professional support networks. Your participation in this research helps us in several ways. In the long run, we're building new knowledge about science education. We'll help future science teachers be more effective. But we're also using research to do our work better each year of the project. Every year, we learn things from listening to you and collecting data that we use to improve our units, assessments, and professional development for our use the next year. So thank you for your participation and ideas, and we'll tell you a little bit about the work of each of our research teams.
Hi, my name is Emily Scott, and I'm a postdoctoral researcher on the student learning portion of the Carbon Time Project. One of the things that I'm investigating is how students reason through inquiry investigations about carbon transforming processes like plant or animal growth. And these kinds of investigations make use of mass balance data, which are data that track how matter moves through a system. And in order for students to be successful in interpreting these kinds of data, they need to be able to link changes in mass with the movement of matter between different components of the system that they are investigating. So I'm looking at 2 research questions. The first research question is, how do students evaluate competing claims about a particular carbon transforming process? And the second question has 2 parts, and it asks, what are the patterns that students identify in data that are generated by an investigation? And then how do they use those patterns as evidence to create arguments that either support or refute the different claims about the system that they are investigating? So one of the important or interesting findings from this work is that students who can craft sophisticated explanations about how a carbon transforming process works aren't necessarily successful at using data from an investigation about that same process to support their explanation. And this is important because it highlights to us that constructing explanations and constructing arguments using data are different practices that need different scaffolding approaches to help students be successful in executing them. So we're using these results to revise the Carbon Time curriculum so that it better supports students in mastering both practices of constructing explanations as well as using evidence to critique different claims about the systems they encounter. So thanks again for your hard work collecting data to support our research.
Hi everybody, I'm Jenny Newell. I teach biology at Nathan Hale High School in Seattle, Washington, and also help lead the Washington network of teachers over here who are using the Carbon Time curriculum, meaning I get to work with teachers in Seattle and Shoreline and Everett and Vashon and Renton and whoever else signs up this year, and we're excited to have as many people on board as we can. So I just wanted to share a little bit about my experience both as a teacher using the Carbon Time curriculum and also my other hat working as a curriculum specialist and a network lead and working with the people in Michigan, because they're 2 different roles, but I love them both. So first, as a teacher, I've been using Carbon Time in my classroom now for a couple of years. We use it at my school for 1 semester of our biology class to learn about transitions in matter and energy. And it's been great at helping our students engage in understanding really tricky ideas ranging from how does somebody lose weight and what's going on there and what's climate change all about. And it scaffolds their 3D learning so well and gets them talking to each other, which is so much better than just listening to me drone on about something and then testing them on it at the end. And then I also help run the network over here. So that means that my colleague Mary Margaret Welch and we run the professional development, both face-to-face and the online PD, and get to interact with teachers all over the area who are using Carbon Time and learn from each other and help each other learn from each other, which has been really satisfying because teaching can get lonely. And so this is a great way to extend your network and learn from more people. And then finally, something that I had a great opportunity to do this year was we as teachers, we always have kind of a gut instinct as to what's working and what might not be working. But this year I really got to research it, and I got to try out some ed research. So I worked with a couple of grad students in Michigan, Krista and Marcos, and Andy Anderson and Mary Margaret Welch, and we worked together to do some research on why are some students more successful than others. And then we presented our findings at the NARS conference in San Antonio this year, which was so much fun and such a great experience. But basically, in a nutshell, just to share our findings, we found that students who were given an opportunity to really engage in scaffolded 3D learning, which is what Carbon Time does, those students, especially those who typically struggle, are successful. They really grow, and we see them improve their understanding. So it's been really satisfying to actually not just feel in our guts like, yeah, this feels like it's working, to see in the research like it's working and it's helping our students. And so that was immensely gratifying. So I've really enjoyed working with Carbon Time and teaching Carbon Time, and hope that you also have a great experience with it. Thanks.
Hi, my name's Wendy Johnson, and I've worked on the Carbon Time project for 4 years now as a graduate student. I'm going to tell you today about the research that we've done using the classroom videos. Hannah Miller and Christy Morrison-Thomas and I have spent the last year looking at the Systems and Scale videos from the 2015-16 school year. And we were especially interested in how classroom talk fosters scientific curiosity, and also principle-based reasoning, so using the principles of matter and energy. And the new standards really emphasize the importance of phenomena in the classroom. So we were looking at it from that lens, where old traditional science education has been described as learning about science, where the next generation science standards are focused on figuring out phenomena. So we're looking at the talk in classrooms and seeing, what's helping students to take on this role of figuring out phenomena. And of course, the Carbon Time curriculum is directed at that as well. So in terms of curiosity, I was looking at how driving questions about the phenomena get established during a unit and how they get carried through each of the activities. And I noticed that in many classrooms, the driving question isn't really explicit. So they may start with that expressing ideas lesson, but students' original questions about the phenomenon and ideas are sort of left behind. And in a classroom, it's really easy to just sort of fall into, today we're going to burn ethanol, and tomorrow we're going to model it. But it seems to be really helpful when the teacher is explicitly stating that driving question over and over. So explicitly saying, remember, we're trying to figure out what happens when ethanol burns. So that's why we're going to burn ethanol today and collect evidence. And then the next day when you're modeling, saying, so, we have some evidence about what happens when ethanol burns, but we still have these unanswered questions that we identified. And so this is how the models will help us answer those unanswered questions. Hannah was looking more specifically at how the principles of matter and energy were used in the classroom. And she found that, again, almost all of the classrooms are really referencing the 3 questions. They're referencing the rules, like atoms last forever. But in some classrooms, they are just sort of rules and just sort of 3 questions that we're answering. Where in other classrooms, those are really used as thinking tools. So instead of just saying, remember, atoms last forever, a teacher might say, well, if atoms last forever, what does that mean for us here when the ethanol lost mass? And helping the students see that, the mass must have went somewhere, and so we have to figure out where that mass is when ethanol burns and, the mass decreases. So These are really, really challenging. We're trying to manage the activities in the classroom and 30 kids and everything that's going on, but really focusing on thinking and figuring out are really important, and helping students see that when we're using the 3 questions, when we're applying the rules, when we're talking about our initial ideas and questions, these are all in service of figuring something out about the world. And these are scientific ways of thinking that help us to develop those scientific explanations for phenomena.
My name is Elizabeth de los Santos, and I have been working as a graduate student researcher on the Carbon Time Project for the past 2 years. I've been on the case study team, network, and teacher learning research groups. In my research, I've been looking at teachers' sense-making about carbon time, and there are 2 things that I found that I'd like to share with you. The first thing is that it's really important for teachers to be student-centered. And what this means in the context of carbon time implementation is that teachers are engaged in sense-making about how to bridge the gap between what their students know and are able to do and what the curriculum offers. So one outcome of this sense-making could be a decision to modify the curriculum materials in ways that both support their particular population of students and also maintains the integrity of the curriculum and what it was designed to do. The second thing is that it's important for teachers to engage in sustained sense-making over time. So as teachers navigate the professional development and classroom enactment settings over the 2 years of participation in the project, it's important that teachers are given opportunities to engage in sense-making both individually and collectively in order to reason and think about ways that the curriculum can best support their students. So the findings of my research will be used by the network leaders and the PD team to better design professional development that will support teachers in engaging in thoughtful sense-making about the curriculum materials, and that will hopefully result in better student learning.